All metals combine with oxygen to form metal oxides. Metal plus oxygen, metal oxide. For example, when copper is heated in air, it combines with oxygen to form a black oxide, cupric oxide. Similarly, aluminum forms aluminum oxide. We learned that metal oxides are basic in nature. Metal oxides are basic in nature. Some metal oxides such as aluminum oxide, zinc oxide, show both acidic as well as basic behavior. Some metal oxides react with both acids as well as bases to produce salts and water, known as amphoteric oxides. Aluminum oxide reacts in the following manner with acids and bases. Aluminum reacts with hydrochloric acid to form AlCl3. Aluminum oxide reacts with sodium hydroxide to form sodium aluminate and plus water. Most metal oxides are insoluble in water, but some of these dissolve in water to form alkalis. Some sodium oxide and potassium oxide dissolve in water to produce alkalis. Sodium hydroxide and potassium hydroxide alkali. Case solution. Metals such as potassium and sodium react so vigorously that they catch fire when kept in the open. Sodium and potassium, hence to protect them from accident fire, they are kept immersed in kerosene oil. At ordinary temperature, surfaces of metals such as magnesium, aluminum, zinc are covered with a thin layer of oxide. Magnesium, aluminum, zinc, lead, etc. The protective oxide layer prevents the metal from further oxidation. Iron does not burn on heating, but iron fillings burn vigorously when sprinkled in the flame of burner. Copper does not burn, but the hot metal is coated with a black layer of copper to oxide. Silver and gold do not react with oxygen even at higher temperatures. Anodizing is a process of forming a thick oxide layer of aluminum. Aluminum develops a thin oxide layer when exposed to air. The aluminum oxide coat makes it resistant to further air corrosion. The resistance can be improved further by making the oxide thicker. During anodizing, a clean aluminum particle is made the anode. A clean aluminum particle is made anode and electrolyzed with dilute sulfuric acid. The oxygen gas evolved at the anode reacts with aluminum to make a thicker protective oxide layer. The oxide layer can be dyed easily to give aluminum particles uh, an attractive finish. The reaction of magnesium is less vigorous, implying that it is not as reactive as sodium. But burning in oxygen does not help us to decide about the reactivity of zinc, iron, copper, or lead. Metals react with water and produce metal oxide and hydrogen gas. Metal oxides are soluble in water, dissolve it to further form metal hydroxide, but all metals do not react with water. Metal plus water, metal oxide plus hydrogen, metal oxide plus water gives metal hydroxide. Metals like sodium and potassium react violently with cold water. In case of sodium and potassium, reaction is so violent and exothermic, the evolved hydrogen immediately catches fire. The reaction of calcium with water is less violent. The heat evolved is not sufficient for the hydrogen to catch fire. Calcium starts floating because the bubbles of hydrogen gas formed stick to the surface of the metal. Magnesium does not react with cold water, it reacts with hot water to form magnesium hydroxide and hydrogen. It also starts floating due to the bubbles of hydrogen gas sticking to the surface. Metals like aluminum, iron, and zinc do not react either with cold or hot water, but they react with steam to form metal oxide and hydrogen. Metals such as lead, copper, silver, and gold do not react with water at all. Metal dilute as metal plus dilute acid gives salt plus hydrogen. Hydrogen gas is Hydrogen gas is not evolved when a metal reacts with nitric acid. It is because HNO3 is a strong oxidizing agent. Nitric acid. It oxidizes H2 is produced to it oxidizes H2 produced to water and itself gets reduced to the nitrogen oxides N2O, NO, and NO2. But magnesium and manganese react with very dilute nitric acid to evolve hydrogen gas. The reactivity material decreases in the form of magnesium greater aluminum iron greater than zinc is greater than iron. In the case of copper, no bubbles were seen and the temperature also remained unchanged. This shows that copper does not react with dilute HCl. Aqua Regia is the presence of concentrated hydrochloric acid and nitric acid in the ratio of 3:1. It is Aqua Regia is highly corrosive fuming liquid. It is one of the few reagents to which the gold.